All right, all right. Thank you for watching this video. Today I'm going to be working on 3-2 Saval's homework or direct variation. All right, let's go ahead and get started. So problem number 1 says, for the data in the table, tell whether y varies directly with x. If it does, write an equation for the direct variation. All right. So in this case, first thing I'm going to do is write down the table that was given to me. All right. All right, so we needed our table. All right, so I'm going to copy my table first of all. I'm given x and y. I am copying it on a piece of paper. Negative 25, 35, 1, negative 1.4, and lastly 20 and a negative 28. Now, how do we know we have a direct variation, right? The keyword here is tell us whether y varies directly with x. Well, if you saw the notes, a way to tell when we have a direct variation is if our points themselves have a common ratio. Now, don't get it confused with slope, right? Although you will find out that this is similar to slope, but a way to find out is that the ratio between all the x and y coordinates are the same. So if you guys remember, you guys took notes, we have that the constant of variation k is equal to y over x. All right? That is the constant of variation. So to tell whether this table represents a direct variation, we just take the ratio of each point. So we first start out with the first point, which is 35 over negative 25. Right? I'm going to do that for all 3 points. Negative 1.4 over 1. And lastly, negative 28 over 20. Now, of course, you're more than welcome to punch this in your calculator and simplify it into a decimal. But remember, in our case, we always like fractions. It is best to simplify, so I'm going to simplify each fraction here. So here, I am left with a 7 over 5 negative. Here, I am left with a common factor of 4, which is a negative 7 over 5. And lastly here, I can multiply both of these by 10 to get a negative 14 over 10, which again, when I simplify this, gives me a negative 7 over 5. As you can see, all these three are the same. They all have a common ratio, or rather, each coordinate point, when written as a ratio, y over x has the same negative 7 fifths, negative 7 fifths, negative 7 fifths. So because all these 3 points have the same ratio, this is a direct variation. So yes, it is a direct variation. All right. So let's go to the homework. And it says write the equation. So if it is, write the equation. So going back to the notes here, remember, what does this give us? This gives us our constant of variation. If you guys remember what a direct variation equation looks like from the notes, all it is just this: y equals kx. Well, if you guys remember, y and x are just an input and output, input, output. They are variables. The only equation, or rather the only variable we have to find is the k, and I just found it. It's negative 7 fifths. So there is my equation. Y equals negative 7 fifths x. All right, so here, again, it says use integers or decimals. So in this case, it wants you to use decimals. So make sure that you are entering in decimal form. Again, I did it in fractions because this is what we do. But in this case, if you turn all these into a decimal, you get a negative 1.4. So my equation is y equals negative 1.4x. Answer, there it is. All right, so that's problem number 1. Let's go to problem number 2. Problem number 2 says, for the data in the table below, does y vary directly with x? Same situation, right? They're giving us some coordinate points. They're giving us a table with x and y. So again, a direct variation means that every point is a ratio, right? And every single point has that same ratio when simplified. So again, I'm going to start off by writing my table. In this case, my table is x and y. X is 2, 3, 6, 3, 4, 7. All right. So here's my table. So again, how do we know if we have a direct variation? Our constant of variation, k, which is simply the ratio of output to input, y over x, should be the same for every coordinate point. So here I'm going to write each one, right? I have y over x for each coordinate point. So I have 3 over 2 for the first point. We have 4 over 3 as the second point, and 7 over 6 as my third point. Again, you can tell that these are not equal. Why? Because this is 1.5 as a decimal. This is 1.33. And lastly, this is 1.16, I believe, with the bar repeating. So as you can see, these are all different. 1.5 does not equal 1.33, and 1.33 does not equal 1.16. So this is not a direct variation. Not a direct variation. So in this case, this is not a direct variation. Y does not vary directly with x. Again, because we understand that the points are not a common ratio. All right, all right. See how much time we got here? Give me 1 second. Halfway. All right, all right. Let's go to problem number 3. Problem number 3 says, if y varies directly with x, find the constant of variation k and the direct variation equation for the situation. All right, so this is a multi-part question again. So let's take it step by step. First part says, if y varies directly as x, all right? What that is telling us is that we have a direct variation. Y varies directly with x. So we have to start thinking of the equation we're going to be using, which is y equals kx, right? And they gave me something really important. They gave me an x and a y coordinate, right? So I'm going to first begin by writing my equation of a general direct variation. All right. And I'm also going to write down the important information they gave me, which is y equals 2, and, or rather, when x equals 1/6. All right, so that is very important. So I wrote down the important information here, right? So again, it says if we have a direct variation, which is this equation, y equals kx, given these 2 points, they first want me to find k, right? So find k, and then write the equation more than likely, right? So, well, let's look at this, right? How do we find k? Well, if you guys notice, it's actually a literal equation. We can go back to 1-3, right? We're given the equation y equals kx. If we want to find k, if we want to isolate k, how do we do that? Well, we got to get rid of the x. Or we can treat x as a quote unquote constant, right? Like a number. So how do I get rid of that x? If I'm multiplying here, I'm going to divide. So k is y over x. Simple as that. So again, notice how this always tends to repeat. Anytime you want to find the constant of variation, k is always y over x. Simple as that, right? So now, why is this important? Well, look, now we have the y and the x that we can substitute back into this equation. So to find k, well, we know k is y over x. So I'm going to plug in or substitute my values. It says k is y over x, y is 2, divided by x is 1/6. Now be very careful here. Make sure that you're plugging this correctly into your calculator, right? And I will do that now so you get the visual. Pulling up my calculator. Again, I'm going to go calculator. We have a fraction. So I'm going to enter the fraction icon here. And it was 2 divided by 1/6. And notice how this looks like this. It's 2 divided by 1/6. Looks like it does on my paper, as you can see. 2 divided by 1/6. So make sure the way it looks on your calculator is how it looks on your paper. You hit enter. There it is. 2 divided by 1/6. I get 12. So my constant of variation is 12. All right. Again, my constant of variation, 2 divided by 1/6, is going to be 12. So my constant of variation is 12. Going back to the homework here. So I said find the constant of variation. So the constant of variation is 12. That is the first part. Second part says find the direct variation equation. Well, we just figured that out, right? Again, going back to the notes, we know that the direct variation equation is always y equals kx. Again, going back to understanding, right? We know that x is my input, y is my output. The only variable we can actually fill in there is the value of k, which is the one that we just found. So I'm going to plug it into this equation and I get y equals 12x. And that is my constant of variation equation, y equals 12x. So don't forget, we have to enter the equation y equals 12x.